these first 5 minutes are will be confusing, will not be tested. You're not required to know how to derive, how to find the quadratic formula. So as I'm speaking in the next 5 minutes, if this is causing you math angst, you can say, you know what, I'm just going to watch her and not worry if I understand or not, right? This is a bit like try to understand one step that I did. If you can understand one step, see if you can understand two steps. But it will be confusing because what I'm doing is I'm using something that I know and I'm coming up with another tool. We call this deriving. Derivations are difficult and you're not expected to know how to do them in grade 10, but I do want to show it to you. I want to expose you to one. And I want you to sit engaged, but confused. Most of you are just going to be like, what is she doing? And you know what? That's good. It's good to sometimes, it's good to be okay with being confused, but not checking out. Got it? Don't be like, well, she said it's not on the test. She said I don't need it. So she said I'll be confused. So I'm just not going to listen. No, no, no. This is an opportunity to challenge your brain. Every single brain in this room is going to be challenged. Every single brain. So you give yourself your own personal challenge. Got it? The minimum challenge is try to understand one step of what I did. Got it? So we're turning on our brain. We're using our math courage. I know this is going to be math scary, but I'm really going to try. And at the end, if I have no idea what she did, it's okay. Got it? Okay. So we're going to come up with something called the quadratic formula. And the quadratic formula is just another tool that we can use to find solutions. It's another tool in our toolbox. Once I derive it, once I figure it out, I don't need to know how I found it, right? I'm just going to use it. Like, look, it's right here. This is a formula. What we're going to do is we're going to find the A, B's, and C's, and once we have the A, B's, and C's, we just put them into the formula. But I do want to show you how we get to this. Okay, so this is the finish line. How do we get there? Well, we start with a standard equation, right? So standard means you have ax squared plus bx plus c equals 0, right? That's the standard equation of a quadratic. If you understand that, give yourself 1 point. Well done. Star. Now, my goal, if I look at the finish line, I'm like, oh, look, the x is on one side, everything else is on the other side. So my goal is to isolate x. Well, what can I do with the c? I can subtract it, or show me with your hand what you're going to do. Where are you going to move it? Over there. Okay. Hey, c, you don't have an x. So if I move the c to the, and oh, another thing I want to say, you don't have to write this down. If you prefer to just watch me and really try to understand, go for it. Like, you will never have to regurgitate this in grade 10. Okay? So do whatever is best for your brain just to follow as much as you can. Okay, step 1. If you understood what we did, little pat on the back. Well done, Miss Sly. Great. Now, I really want to isolate x, but I've got x in 2 terms. So I'm going to start with the x squared. How do I get rid of the a? I'm going to divide every single term by a. And that's going to mean that I can I can cancel out the a's in front of the x squared. Okay, where does that leave me with? Well, it leaves me with an x squared plus b over ax. Now we're going to leave some space because I'm going to do a crazy step now. Leave some space here. C over a. I'm going to do the crazy step in, I need a better color. I need a light green. I'm just feeling it. Okay. Yeah. Why is it b over ax? Oh, the x is actually not in the denominator. I meant to show it that it's like b over a as the fraction. Do you know what I mean? It's like writing 1/2 x. Yeah. Yeah, so I can do that. I can take bx over a, and I can say it's the same as going b over a times x. Okay. Now, I'm doing something called completing the squares, which you have not learned yet. So I'm taking this middle term. Okay, I'm taking the b over a. Don't worry why I'm doing it. So I'm taking the b over a, and I'm going to divide it by 2. And I remember that if I'm dividing a fraction, I'm multiplying it by the reciprocal. Meaning I'm going to multiply b over a times 1/2. And then I multiply the tops. So b times 1 is b. And I multiply the bottoms. A times 2 is 2a. That's a little side step. Now, you're not going to understand why, but to each side of the equation, I'm going to add this term, b over 2a squared. Because I did it to one side, I need to add it to the other side. And I'm adding it in front on the right side because it's just going to make sense and look the way we need to have it look. Now, I'm going to factor this trinomial. Here's a challenger. What kind of factoring method can I use? Which is it? Is it difference of squares? Is it decomposition? Is it simple trinomial? Or is it perfect square trinomial? Yeah, it's a perfect square trinomial. Watch this. What is the square root of x squared? X. What is the square root of b over 2a squared? Well, you just get rid of the squared. There's a plus in the middle term, so I draw a plus. This is a perfect square trinomial. Again, if you're not following, don't sweat it. On the other side, I'm going to square this first fraction. I'm going to have b squared over, and if I square the bottom, I have 4a squared minus c over a. Okay. Oh, no. Oh, yeah, c over a. Now, on the right side, I don't I need to subtract these two fractions, and I need them to have a common denominator. So in order to make a look like 4a squared, what must I multiply it by? To get 4a squared here. Yeah, so I need to multiply it by 4, and I need another a. And that means I'll multiply the top by 4a. Okay, folks, you're doing really well. I see you're engaged. I see you're trying. Awesome. Okay, what does that give us? So on the left side, we get b squared over 4a squared minus C times 4A, 4AC. On the bottom, I have 4A squared. Oh, that's good, because now I have the same denominator. So on the right side, I can say, I'm going to make it all one fraction. On the right side, I'm just going to copy down what I have. Now I want to isolate the x. So how do I get rid of this stuff? What's the opposite operation I'm going to use to get rid of that stuff? I will use a minus at what point? At one point. What will I do before the minus? Square root. See this squared? I get rid of it by taking the square root of both sides. And does anyone remember what I have to do from yesterday when I take the square root and a variable is involved? What do I write in front of the square root? Nice. Really good. Okay. So the square root and the squared cancel each other out. So on the left side, I'm left with 4 plus b minus 2a. On the right side, I recognize that I can take the square root of the top and the bottom of the fraction separately. So I'm going to have positive negative b squared minus 4ac over 4a squared. What is the square root of 4a squared? What's the square root of 4? And a squared is a. So I've got positive negative b squared minus 4ac over 2a. Okay? This is a lot of steps and a lot of confusion. So with this, I've got x plus b over 2a, and Zeta said, well, we're going to minus, right? We're going to take this term and move it to the other side so that I'm left with x on its own. The b over 2a becomes negative. And then I have plus or minus this whole thing. B squared minus 4ac, all under a square root, over 2a. Last thing I do, what do you see that I can do on the right side? I can combine them because they have the same what? They have the same denominator. Okay, so that means the denominator is 2a. I have negative b plus or minus b squared minus 4ac. Did I get to the finish line? Is it the same as where I was supposed to get? Yeah. This is the quadratic formula. Folks, I would like you to put your hand up if you understood one step that I did. Turn that hand around. Give yourself a pat on the back. Now, put your hand up if you tried to understand the whole process, if you stayed engaged for more than 75% of what I did. Pat on the back. Like, really, congratulations. Has anyone ever done a derivation like this? Maybe some people have. Who's never seen this kind of thing happen? Yeah. Who was confused? Yeah, of course you were. Congratulations. Your brain just, can you feel it? Can you feel your brain like popping out of your skull? Like it's like growing. It's growing fast. Yeah. So I want to really congratulate you. We did something difficult and you really stayed engaged. And I know whose brain is tapped out. Like, let's be honest. Whose brain is tapped out? Oh yeah. Everyone else is like raring to go. Yeah, I think you're tapped out. I don't want to push you more. So I'm switching up our schedule a bit. I'm going to teach the rest of this lesson tomorrow, and we'll do a couple of word problems tomorrow. Okay? What I want you to do for homework, because we just got to the fractions and the word problems, I want you to do those questions that, oh, let me stop the video.